Chapter 5. The Rope Stretchers. Now, at last, came the dawn of civilization, and with it, practical geometry got off to a real start in the work of the surveyors or rope stretchers. To build the earliest civilizations, people had to get along together in settlements. Living in groups meant great advantages and also great responsibilities. The people who lived together in the protected valleys of the Nile and the Tigris and Euphrates recognized this. We have the proof of in their ruins. Each early civilization, as far back as several thousand years BC, has left on the land the traces of field markers, irrigation canals, and storage basins. The very earliest tracings go back to about 5000 BC, the date that archaeologists gave to the village of Jamaro in Iraq, perhaps the oldest known village in the world. And many of these ruins reveal the work of skilled surveyors. They are laid out with straight lines and right angles. Nowadays, we take right angles for granted, but have you thought about a big part they play in our lives? If you have flown over farmlands, particularly in America and Australia, you have probably noticed that the scene below resembled a patchwork quilt, for the fields are laid out in rectangular patterns. Fences divide one piece of property from another in the same rectangular patterns, and the corners of a rectangle are right angles going back. Right angles everywhere. As you drive along through the country, have you noticed that the telephone poles, fence posts, trees, and houses all stand upright and at right angles to the ground? Can you imagine a landscape without the right angle? Try to picture driving at 50 miles an hour with poles standing every which way, and suppose houses and windows slanted in any direction, and the walls of a room were closed inward. You could quickly feel quite disoriented. Today, we are all so familiar with the right angle that we don't even notice it. Look around the room. How long do you think it would take you to count all the right angles you see? Even in this book, right angles form the four corners of each page. They appear in the structure of the letters L, T, E, and H. In modern times, right angles, like circles, are everywhere. But ancient civilizations did not take the right angle for granted. It was a significant discovery made with the aid of a string. It fills needs that were important to people living together in communities. One very big problem of the early farmers was to mark off their fields for property rights. They had to protect their own property and respect the property of others to get along in peace and security. What was the best shape for their fields? Remember, these were among the first fields ever laid out. People were familiar with the winding shores of lakes, the jagged lines of mountain ranges against the sky, the endlessly varied outlines of the clouds, but irregular boundaries for a field would not be practical. Ancient people did have a regular pattern to turn to, however. Even in their primitive days, they had known how to weave reeds into mats to cover their earthen floors. The characteristic of the warp and woof in weaving is rectangular, and just as a woven mat covered the earthen floor, so could a rectangular form mark off the boundaries of their fields. Yes, the rectangular shape worked in weaving, but how could that shape be marked on the earth? Marking a right angle. We know part of the early solution. Pictures on tomb and temple walls show how ropes were used as measuring devices. To make a strong rope, people could use a sturdy vine or twist reeds together, and a stretched rope would mark the boundary between two neighbors. But there were neighbors on all four sides, not just one or two sides. At first, the corners may have been marked off freehand, but people wanted something more dependable than a freehand boundary. The big question was how to mark an accurate right angle corner. Exactly how this was done in Mesopotamia or Egypt is a question that historians may never be able to answer, but we have some tantalizing clues. In the wall paintings of thousands of years ago, there are pictures of Egyptian surveyors dragging a knotted rope. From that custom, the ancient surveyors seem to have been called rope stretchers. And apparently, those ancient rope stretchers knew that certain dimensions, so many knots or spaces on each side, would make an accurate right angled triangle. How did they find out? Perhaps the discovery was made and lost many times. We can only imagine the way it might have happened. Perhaps the day was very hot and some Egyptian rope stretchers got more tired than usual, laying out a right angle by an old guesswork method. The idea was to make a straight line and then another cross it in the middle. This was hard work in the blazing sun. It took 3, sometimes 4 of their measuring ropes with evenly spaced knots. First, they had to lay the straight line. That meant hammering 2 end stakes firmly into the ground with a knotted rope stretched tightly between. Then they found the middle of the line and drove in the center stake. Next, they took a much longer rope with plenty of play and fastened it to the 2 end stakes. Seizing this rope by the middle, they pulled it as far as possible to one side, opposite the center stake, and drove in a side stake to hold it there. Finally, they stretched a cross rope from this side stake back over the center stake. That ought to be a right angle, but the overseer was fussy, so they would have to do the same thing over again on the other side, and then keep at it the rest of the day until they lined up the ropes perfectly. Perhaps at noon, when the whole crew stopped to rest in the scanty shade of a clump of palm trees, one rope stretcher stayed behind, wearily studying the knotted ropes stretched on the ground, maybe remembering that long ago they used to find the middle of a rope by laboriously folding it in two. But nowadays they were just used ropes with an odd number of knots and counted spaces to the center knot. Wasn't there some simple way to count for a right angle? The rope stretcher began counting. There it was, the 3, 4, 5 right-angled triangle. 3 spaces between the knots on one arm, 4 spaces on the other arm, and 5 spaces on the long side opposite the right angle. Naturally, the rope stretchers shouted to the others to come and see. These easy dimensions on the single rope would give them the form they needed so badly. And with hardly any work at all, the rope knotters would even make a special rope with large knots already spaced in the dimensions of 3, 4, 5, and they could peg it anywhere to make a right angle triangle in a few minutes. By some such accident or series of accidents, the string disclosed yet another secret, the perfect right angle. Measure and repeat. Now that surveyors could mark off accurately with rope all the sides and corners of a field, they had ample practice. For every year when the floods came and receded, the carpet of rich black soil buried the boundary markers and the fields had to be remeasured. Digging level ditches. The rope stretchers had another big problem too. The flood season was followed by a long dry season, for which some preparations had to be made. A network of canals was needed to irrigate the land. Digging them created new difficulties. If you have ever tried to dig a ditch, you know how hard it is to keep the bottom level and the sides at right angles to the bottom. But this is important if the ditch is to hold water. Water does not run uphill, and if it runs downhill, it flows into one spot. A way had to be found to level the irrigation ditches and straighten their walls. To do this, the rope stretchers took 2 straight sticks of equal length and spliced them together to form a right angle. Then they reinforced this angle with a crossbar, which made a shape something like our letter A. Finally, they hung a weighted string from the vortex of the angle. When the 2 sticks which formed the angle were on level ground, the string hung straight down through the center of the crossbar. If the ground was not level, the string hung off center. To make sure that the side of the ditch was vertical, they hung a weighted string against the side. Thus, with the level and plumb line, they performed the all-important work of surveying ditches and canals. Measuring area. The rope stretchers also helped with one other major problem of community life: taxes. Because taxes were paid according to the size of a field, the way of measuring area had to be found. For measuring length, there were 2 available ways. A rope could be doubled by using it twice, or halved by folding it. A rope with evenly spaced knots was a good measure. Also, parts of the body which could be used as units of length. For instance, the breadth of a finger, the width of the palm, or the span of the outstretched hand from tip of thumb to the tip of little finger. And do you know that the dimensions of Noah's Ark are given in cubits? A cubit is the distance from the elbow to the tip of the longest finger. But the human body does not provide convenient units for measuring area. People had to describe the size of a field by a morning's work or a day's work for a yoke of oxen. But some farmers worked faster than others, and so did some oxen. You can see how disputes would arise. Even early on, people realized that exact measurement was a good way to keep peace. Again, the idea of weaving came to the rescue. In their woven mats, ancient people could see a design of little squares, and they could construct a square by making the sides of a rectangle equal. The square became the unit for measuring area. Naturally, solving all these problems made the rope stretchers very important people in the early communities. Conversely, important people were proud to be rope stretchers. Rope stretchers and pharaohs. In ancient Egypt, when the Nile overflow clogged the irrigation ditches with mud and buried the boundary markers, whole villages would go out together to clear them. The leading rope stretcher of such groups was the local chieftain who supervised the work. To these local chieftains, the people paid their taxes with shares of grain or flax according to the size of their property. They also gave them the respect bordering on veneration. Since the whole civilization depended upon water, which nourished the fields and gave food, these early rope-stretching chiefs were looked upon as divine givers of life. From their number came area chiefs and finally a national leader who was the start of the long line of Egyptian pharaohs. Building the pyramids. For the burial of the pharaohs, the ancient Egyptians built the great pyramid tombs that are still admired by travelers today. These pyramids are masterpieces of ancient practical geometry. Even now, they are enduring monuments to the accuracy of the string made right-angled, triangle, and square, and the early appreciation of sturdiness in the pyramid form. The first pyramid. The world's oldest stone structure built by people is the step pyramid tomb of Saqqara. It was built by about 2700 BC. Its square base was pegged off with a knotted rope. In receding steps, it tapered to a peak on top, and it was the forerunner of the true pyramid form. With the right angle, the pyramid builders laid out accurate direction lines. They accepted the direction in which a shadow always pointed at noon as the north-south line. By drawing a line at right angles to it, they got an east-west line. These two were always their base lines. The sides of the pyramid's square bases face exactly to north, south, east, and west, and this precision was achieved thousands of years ago. The Great Pyramid was built around 2550 BC. A wall drawing has survived that shows us the actual start of the work. It depicts all the pomp and grandeur of the ceremony connected with laying out pyramids and temples in that period, just as laying the cornerstone of an important government building brings out officials today, so marking off the ground plan of a pyramid was a great occasion almost 5,000 years ago. The place was selected, the rope stretchers were on hand. Amidst great crowds, the pharaoh and his retinue marched to the scene to perform the ceremony. This impressive occasion was called the putsur, which means to stretch a cord. The ancient picture shows the pharaoh holding a golden mallet, and the inscription tells us that the pharaoh spoke words befitting a royal rope stretcher. I have grasped the wooden peg. I hold the handle of the mallet. I grasp the cord with Seshata, the goddess of the stars. I cast my face toward the course of the rising constellation. I let my glance enter the constellation of the Great Bear. I establish the four corners of the temple.